Hashing. Let us see the presentation about hashing. Next, here are our team members Tejasri, Lakshmi Sudha, and Satvik. Next, what is hashing? Hashing converts an input key like name or a string into a numerical index. Fixed index storage. This computed index points to a specific location in a data structure called a hash table. Average order of one operations. It provides near instantaneous average time complexity for searching, inserting, and deleting data. Next, real world challenge. Let us see the real world challenge on hashing. Searching phone contacts. Imagine your phone book filled with hundreds or even thousands of contacts. When you type a name, you expect immediate results. Linear search checking each contact one by one takes order of n time, becoming very slow with many entries. Many contacts might have similar names, complicating simple alphabetical searches. Users demand instant feedback, slow searches lead to a poor user experience. Next. How hashing solves the contact search problem. Input name. The contact's name is passed to a hash function. And the hash function computes a unique or near unique index. Stores at index. The contact is stored directly at this calculated index in the hash table. Instant search. For searching, the same process occurs, leading to a direct jump to the contact's location. Even when two names collide, hash to the same index, efficient strategies like chaining or probing ensure quick access. Next, hash function. Name to number. A hash function takes an input, the key, and returns an integer, which is indexed in our hash table. Ravi might convert to index 23, Kiran might convert to index 42. This deterministic process ensures that the same name always maps to the same index, allowing for consistent storage and retrieval. Next. Here is the hash table structure. The hash table is essentially an array where each index can store data, often a list of contacts to handle collisions. Here you can see examples for Sita, Ravi, and Kiran. Each index points to a specific bucket where one or more contacts can reside. Next, collision handling. Chaining. What happens when two different key hashes to same index? This is called collision. And here you can see the example for collision. Arun hashes to index 27. Anu also hashes to index 27. Chaining resolves this by storing a linked list at each index of hash table. When a collision occurs, the new entry is simply added to the end of the linked list at the end. Here you can see structure. Index 27 points to Arun, points to Anu, and it points to null. Next, we can see the code here, contact storage with hashing. Here we can see the code of hash table and hash function, how it implements. Next, also insertion and search, how it implements in our real-time problem. Next. Hashing broader impact. The principles of hashing extend far beyond just contact lists, proving indispensable in many areas of computing. Databases, accelerating record retrieval and indexing, catching, quick storing and retrieving frequently accessed data, security, ensuring data integrity and password storage, networking, load balancing, and routing decisions. Next, collision handling in hashing. In the world of hashing, collisions are inevitable part of the process. They occur when two different key hash to the same index in the hash table. This selection explores how open addressing techniques resolve these conflicts efficiently.
Open addressing resolving collisions. When a collision happens, one method to handle it is open addressing. Instead of storing multiple elements at the same index, the system searches for another free slot in the table. There are three main techniques. Linear probing, we can check the next slot by one. Quadratic probing, we skip slots in a quadratic pattern like 1 square plus 2 square plus 3 square. Double hashing. A second hash function is used to find a new index. This slide compares all three in a simple diagram. This slide gives a simple example. Suppose Arun hashes to index 9, but 9 is already full. Using open addressing, the system checks the next index, index 10, and finds it empty. So Arun is stored there. This shows how collisions are smoothly resolved. This slide highlights why hashing is so powerful. Traditional linear search take bigger of order of n time because it checks each entry one by one. Very slow for large data. Hashing provides bigger of one average time, meaning instant access regardless the data set size. The graph visually shows the huge difference in performance as grows. Inserting data using hashing follows a simple step-by-step process. Take the input like a contact name, apply the hash function to create a numeric value, convert that into a valid index. Try to store it at that index. If a collision occurs, apply probing or chaining. This makes insertion extremely fast and efficient. Searching is where hashing shines the most. The user enters a name, the system hashes it, directly jumps to the index and fetches the result instantly. Even with the collisions, the search follows a clear path, making the process very fast. That's why hashing is perfect for real-time apps like phone contact search. When deleting, the system again hashes the name to locate the correct index. The method depends on collision technique used. If we use chaining, we remove the node from the linked list at that index. If we use probing, we mark the slot as deleted, not empty, so the search path doesn't break. This ensures a smooth functioning of future searches. This slides give a complete example of how contacts are stored in a hash table. It shows multiple names and how each maps to a specific index. At index 27, both Anu and Arun hash to the same index. So chaining is used, Arun is added after Anu. This visual representation makes collision handling easy to understand. To conclude, hashing is one of the fastest data handling techniques we have. It offers very fast performance, order of one average lookup, easy handling of large data sets, instant access for real-time applications. That's why hashing is widely used in contact apps, databases, caches, and many other systems. These are the references used in the project, standard data structure books and documentations from Android and iOS, and Geeks for Geeks. They provide deeper understanding of hashing concepts and implementations. Thank you.